Welcome. In this video, I want to define the goal we are working toward as a company, building the infrastructure for autonomous semiconductor R&D and manufacturing. UnicornOne is the central element of that vision. Why spend years rebuilding laboratory infrastructure before you can start solving the scientific problems that actually differentiate your work? UnicornOne already provides that foundation. It unifies traditionally disconnected equipment, metrology data, and AI into a single coherent environment. So what makes UnicornOne a lab operating system, or LabOS? Think of Windows. Windows solves whole classes of problems at once: hardware access, communication, security, data handling, APIs, and system services. So every application built on top inherits them. Word does not implement USB drivers. Excel does not implement networking. Photoshop does not implement printer support. They inherit those capabilities from the operating system. UnicornOne does the same for the laboratory. Instead of repeatedly solving hardware integration, data structure, AI integration, metrology, digital twins, data workflows, safety, and interoperability for every new system, UnicornOne solves those classes of problems at the operating system level. Any new physical system, instrument, AI model, or application simply plugs into that common architecture. That's the difference. Control software solves the system in front of you. A LabOS solves the underlying architecture, so entire categories of problems never need to be solved again. Let's start at the bottom. Here, we see UnicornOne's port and device registry. Every connected device is represented through the hardware abstraction layer, giving UnicornOne a consistent way to communicate with hardware regardless of manufacturer or protocol. Serial TCP simulated devices and internal pipelines can all operate through the same architecture. The low-level communication logic is handled by UnicornOne. Users can extend that environment by adding their own devices, libraries, without rebuilding the rest of the control system. And every communication can be monitored and logged. So instead of writing another collection of hardware drivers into another bespoke application, we create reusable hardware abstractions that become part of the platform. Now, let's look at data. A common response we hear is, we already put our data into one database. Well, that's great, but a database full of values is not automatically useful to AI. UnicornOne continuously abstracts, interprets, and secures laboratory information into meta-rich, fair-aligned data. That includes scalar process values, system values, recipes, events, metrology outputs, images, videos, and experimental context. Here, for example, we can search across the UnicornOne SQL databases and immediately relate values back to system, device, process, and experiment that produced them. The goal is not simply to save data, it's to preserve meaning. Because AI does not just need numbers, it needs context. And that structured data does not only come from the control system. UnicornOne includes data ingestion workflows for external instruments and metrology systems. Here we can see the read environment. Live video can be processed using HID filtering, azimuthal scanning, angle locking, and custom analytical algorithms. One metrology source can be handled in the same way as others. The output is not left isolated inside another vendor application. It's brought to the same laboratory data model and becomes available to recipes, dashboard, digital twins, AI models, and external applications. That is the difference between simply connecting equipment and actually integrating a laboratory. Scientific data can also become enormous very quickly. So UnicornOne includes a data engineering logic needed to manage it. That includes data thinning and compression strategies for long-running process values. Lossless camera encoding that will optimize compression, HDF5 exports for scientific datasets, and data workflows designed to preserve high-resolution information where it matters while reducing unnecessary storage overhead elsewhere. These are not glamorous features, but once you are running multiple instruments, cameras, and experiments continuously, they become essential. And again, they are part of the platform rather than something every laboratory has to reinvent. UnicornOne also records more than just values over time. It records what the system was doing and why. Recipe execution, user actions, state changes, analytical events, and process transitions can all contribute to a causal experimental history. That means when something interesting happens in an experiment, we can relate the result back to the conditions and actions that preceded it. For conventional data analysis, that is useful. For machine learning and autonomous experimentation, it becomes extremely important because a timestamp tells you when something happened. Experimental context tells you why something happened. Then there's safety. Laboratory control cannot simply rely on AI model making good decisions. Users using UnicornOne can implement multiple layers of protection around the processes. This includes out-of-range protection, interlocks, preventative rules, and system watchdogs. Hardware and software health can be monitored independently of higher-level experiment logic. So, whether the experiment is being controlled by a human, a deterministic recipe, or an AI model, the same underlying protection remains in place. Intelligence sits on top of safety. It does not replace it. If you want external control, this is already part of the architecture too. UnicornOne provides a comprehensive REST API, exposing laboratory data and control functions. Access can be configured from full read to write control, to read-only, write-only integrations, and no access at all. And communications can be fully logged. That means external software does not need to bypass UnicornOne and communicate directly with laboratory hardware. It can operate through the same structured abstraction used everywhere else. Python application? Fine. Machine learning model? Fine. Cloud services? Fine. The laboratory interface stays the same. That brings us to AI. UnicornOne provides three primary ways to integrate AI and machine learning. And Python recipes can communicate directly with external AI services from within the experimental workflow. The REST API that we just saw allows completely external AI machine learning applications to observe and control the laboratory. AI/ML workbooks allow developers to build complete visual tools and operate as native elements inside UnicornOne. These methods can also be combined. The important point is that AI integration is not bolted onto the side of the control application. It is built into the architecture of the LabOS. Before any of that logic touches real hardware, UnicornOne can also simulate it. Every installation can include a representation of the connected hardware environment. Devices can be simulated, recipes can be executed, failures conditions can be introduced, users can be trained, developers can test, and AI models can interact with realistic laboratory hardware before being given access to expensive physical equipment. This is especially important as laboratories move toward increasing autonomous operation. You do not want your AI model learning what a closed shutter means by discovering it on a real growth run. And the laboratory does not end At the equipment rack, UnicornOne can integrate with spare parts and inventory systems, LIMS, ERP, MES environments, Nomad Oasis exports, messaging services, scheduling systems, and other facility-wide software. So when a recipe needs a human double check, when a component is approaching replacement, when the sample needs to be registered, or when an experiment finishes, these events can participate in the same wider workflow. The result is not simply automated equipment. It is an integrated laboratory. And not every laboratory wants its data leaving the building, so AI does not have to live in the cloud. As part of the wider UnicornOne architecture, business provides a domain-specific open-weight language model trained around MBE workflows and laboratory operation. This model can already perform tasks such as writing growth recipes, opening and closing shutters, calibrating fluxes, waking up the system, or placing it back into a standby state, scheduling samples, and executing those schedules. It can also act as an embedded assistant for operators, explaining the software, guiding new users, and helping interpret laboratory workflows. Because the model can run locally at the edge, sensitive process data and proprietary experimental knowledge can remain inside the laboratory. Cloud, local server, or edge, the infrastructure is yours to choose, but the intelligence is already built into the platform. Demo dashboard. And when we bring all of this together, this is what the operator sees. UnicornOne dashboard acts as a central navigation point for the entire platform. Each major UnicornOne component appears here and lives as a thumbnail whenever it is opened, allowing the users to return to one place to see the whole system at a glance. Recipes, metrology tools, device communications, data views, AI tools, and system monitors can all remain active simultaneously while their live state is reflected back through the dashboard. This means the operator does not have to jump blindly between separate windows, vendor applications, databases, and scripts. They can move through the laboratory from a single, coherent environment while still keeping sight of everything else that is running. And because each component sits on the same underlying UnicornOne architecture, that environment can continue to expand as new tools, devices, and applications are added. So, to wrap things up, could you build some of these things yourself? Absolutely. You could write the hardware drivers, build the SQL database, make it fair aligned, create a read processing pipeline, implement compression, build your own API, add authentication, write the simulation environment, add the watchdogs, create the plugin framework, integrate LIMS, add an inventory, build AI interfaces, create experimental logging, and maintain all of that while your laboratory equipment and research continues to evolve. You could, but why would you? We have already thought about it, all of it, and more, so you don't have to. UnicornOne is not another control application. It is a platform already turning laboratory automation, structured data, and AI into measurable operational results. In existing MBE workflows, UnicornOne has already reduced manual operation enough to save more than $150,000 per system per year in operating costs. It has compressed months of iterative growth development into days through physics-informed process models and repeatable execution. And we have trained AI models on one system and transferred those models to several others, demonstrating that once the laboratory is properly abstracted, intelligence can become interoperable too. That's the promise. Lower costs, higher throughput, better quality, faster material discovery, less downtime, and more capable human operators. With UnicornOne, the infrastructure is already here. You can start using it now.